Welcome to my lesson over probability. So we're going to start off with theoretical probability. And this is going to be the probability that will measure the chance of a specific event will occur. So I do have a typo there. It's supposed to say event, not even. The set of all possible outcomes is what we call our sample space. For equally likely outcomes, the theoretical probability of an event, so probability of E, is going to be the ratio of the number of favorable outcomes, so what we want, to the total number of outcomes. And so here they're giving you an example of how you would set that up. Probabilities values can lie between 1 and 0, but could also, and doesn't happen very often, include 1 and 0. 0 being the chance that it will never happen, and 1 being the chance that it will always happen. You can express this as a fraction, a decimal, or a percent. A lot of times for my kids, I do require that they write it as a fraction because we like to deal with exact answers, but the other ones are options. So then moving on, we have our complement of an event. The complement of an event is going to be the probability that the event is not happening. Since the sum of all probabilities, in a sample space is going to be 1, the probability of an event not happening is going to be written as 1 minus the probability of the event happening. And lastly, we have our odds. Odds are going to be the ratio that is going to compare the number of ways an event can happen. Highlight can. To the number of ways that it can fail, so it would not happen. A lot of times you see that expressed as your number of successes over your number of failures. All right, now let's look at some practice problems. So we have for our first problem here, what are the odds of picking a spade from a deck of cards? Now, for probability, it's going to be essential that you kind of know a little bit about deck of cards. So make sure that you kind of freshen up on such as what is a suit, how many in a suit. We've got our reds and our blacks. We've got how many total cards, things like that you're going to need to know. So for this one here, what are the odds of picking a spade? Well, since we are talking about odds, we want our favorable, so our spades. Which is going to be 13. You have 13 spades in a deck of cards. Over our failures, which is everything that is not a spade. And so to find that, we could take our total, 52, minus our spades. Well, when we simplify here, we could get 13 over 39, which this will just reduce to 1/3. All right, now let's look at number 2. For number 2, if 2 coins are tossed, create a sample space of the possible outcomes. What is the probability of landing or getting, at least one tail to show? So let's start off by just listing out our sample space. So we have 2 coins that are being tossed. Well, when we toss them, we could get heads, so both heads. We could get both tails. We could get a heads, then tails, or even a tails, then heads. All right, so that's going to give us 4 ways of what our possible outcomes could be. And we are trying to figure out how many of them, or what's the probability of getting at least one tail to show. So we got to figure out how many times does that happen. At least one means we could include two. And then here we have 1 and 1. So that's going to be 3, what we want, over our total amount of that 4 that we got. So 3/4 would be the probability of getting at least one tail to show. Then moving into number 3, we have 2 cards are drawn at random from a deck of cards. What is the probability of picking 2 hearts? All right, so remember probability, we're going to start off with our favorable, so what we want. Well, there are going to be 13 hearts in a deck over my 52 total. So this is the fraction for my first choice. I am making 2 choices, and so I'm going to multiply by another fraction. Now, the thing we have to think about, and so for my class, we automatically assume that something is not being replaced unless they tell us otherwise. So when I go to draw again, I'm now going to have 12 hearts because I've already drawn one over 51 cards total. Okay, and so when I multiply these two together, I'm going to just get 1 over 17. Sorry, I just plugged in those 2 fractions into my calculator, and this is the reduced final answer that they gave me. All right, moving into number 4, state the odds of an event occurring if the probability is. So remember, probability is going to be our favorable over our total. But when we're talking about odds is our favorable, so our successes, which means my numerator is not going to change, over my failures. Well, if my success is 4 and my total is 11, I can find my failures by subtracting the 2. So here I would get 4 over 7, which that does not reduce, therefore it would be my answer. Okay, looking at part B, same idea. My numerator should not change, but for my denominator, I would take my total minus my successes, and I'm going to end up with 5 over 94, which once again does not reduce, and there would be my answer. Okay, final one, we have our 3/5. So my total does not change. Sorry, not my total. My numerator does not change. And then in my denominator, I'm going to take my total amount and subtract my success to find my failures, which is going to give me 3/2. Now, something that I reminded my class about, this might confuse you because, this shows to be greater than 1. This would be 1.5. But remember, this is odds. This is not probability that we're finding, and so that is okay. But if you're asked for probability, you should never have anything greater than 1. So let's move into number 5 here, where they ask us to state the probability of an event occurring if what we're given is odds. So if these are odds, remember, once again, we have our successes in the numerator, so that's not going to change, over my failures, but I need total with probability. Therefore, I would add the 2 and the 3, my success and my failures, to figure out what is my total. So 2/5. Then applying that same logic to part B, we have our total, keep saying total, our numerator does not change. And then for my denominator, I would do the success plus failures to figure out my total amount, which would give me 9 over 16. All right, and lastly, we have part C. So once again, my numerator should not change. We have our success is always in the numerator. And then for my total, I'm going to add them together. And I'm going to get 11 over 25. All right, so now let's look at number 6. In number 6, the marble is drawn at random from a bag containing, we have 6 white, 8 red, and 10 blue. We are asked to find the probability that the marble is blue. So because we are finding probability, I'm going to start off with just figuring out what is my total by adding that 6 plus 8 plus 10, which should give me 24. Okay, so what is the probability that the marble is blue? Well, we had 10 blue marbles over my total 24, and this will reduce down to 5 over 12. Then we have find the probability that the marble is not white. Well, in order for that to not be white, it would have to be either red or blue. So there's 2 ways you can do this. We can start off by just saying my red and my blue, so that 8 over, we would have 24 plus 10 over 24. Okay, because there's 2 ways to be successful, so I'm adding them together. And this would give me 18 over 24, which would reduce to, we would have 3/4. Another way you could do the same problem is, as I mentioned earlier, we have that complement where we find the probability of it being white, which would be that 6 over 24, which is 1/4. And then we could subtract from 1. So 1 minus 1/4 would just give me that 3/4 that I ended up with already. All right, and our last one, find the probability of the marble being red or white. We've already kind of talked about this. In order for it to be, we've got our red or our white. We would just add our 2 together. So 8 over 24 for my red. Plus my white, we have that 6 over 24, which this would just give me 14 over 24. And that will reduce to, we have 7 over 12. All right, so moving into our last problem on the front side, we have 1 card is drawn at random from a deck of 52 cards. We are asked to find the probability of the card being a red face card. All right, so in order for it to be a red face card, it could be a diamond or it could be a heart. And so you also need to think about the fact that there are going to be 3 face cards in each one of those suits. And so we have a total of 6 over 52 that would be red face cards. And then that would simplify to, we have 3 over 26. Okay, find the probability of the card being a club. Well, if it is a club, the club is a suit, and there's going to be 13 of each suit. And so we would have 13 over 52, which will just reduce to 1/4. And then our last one on the front side, we have find the odds of the card not being an ace. All right, so remember, odds is our success. So it's not an ace. Well, there's going to be 4 aces, and so I'll just do 52 minus 4 over my failures, which is going to be it being an ace, so that's going to be 4. And that 52 minus 4 is going to become, we've got 48 over 4, which will simplify even further into, we've got 12 over 1. Okay, to clarify, we're going to want that 12 over 1, not just a whole number of 12, because this is a ratio. And so we need to show the comparison of that 12 to 1. All right, now moving into number 8, the back side. So we have one marble is drawn at random from a bag containing, we've got 4 white, 6 red, and 6 green. We want to find the probability that the marble is going to be white. All right, so to do this problem, I'm going to start off with my total. It's going to be that 4 plus 6 plus 6 to give me 16. And so finding the probability that the marble is white, so my success, which would be 4 over my total, which is 16. Okay, so we would simplify to get 1/4 as my answer. Then we have part B, find the probability that the marble is white, red, or green. So for the probability of it being white, we have 4 over 16. Plus we have our red, so 6 over 16. Plus my green, which is 6 over 16 as well. When you add all of that together, you're going to get 16 over 16, which just is going to give us 1 as my answer. All right, and moving into part C, we have find the odds. So seeing that keyword there, we know it's our success over failures of the marble being red or green. So for the marble to be red or green, we're going to add for my successes the 6 plus 6 over my failures. In order to be a failure, we would need it to be white, which is 4. So we'll have 12 over 4, which will reduce to, we'll have 3 over 1. All right, now moving into number 9, we have a 10-speed bike is given as a door prize. A total of 220 tickets numbered 1 through 220 are sold. If the winning number is chosen at random, find the probability of each event. Okay, so for our first part, we have part A, the winning number is going to be less than 101. Well, there's 100 ways for that to happen over my total amount, that 220. And so this will just simplify to give me 5 over 11. Then we have the winning number is greater than 50. So if it's greater than 50, it's not going to include that. And so I'm going to take 220 minus the 50 over my 220, my total, which is going to give me 170 over 220. And that will reduce to 17 over 22. Finally, we have part C. The winning number is between 10 and 21. So we've got 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 that could land us that winning number. And so that's going to be 10 options over my 220 as my total, which will reduce to 1 over 22. All right, moving on, we have 2 more problems. For both of these, we are going to create a sample space. So be prepared to write. Some are going to be longer than others. We do have create a sample space if 3 coins are tossed. Okay, so what are the different ways that they could land us? We have our obvious ones as all 3 heads or all 3 tails. Then I could do head, head, tail. And tail, tail, head. I could do head, tail, head. Or tail, head, tail. I could also do, let's see. We've got head, tail, tail, and tail, head, head. And I believe that is it. So this would be my sample space that we're working with. All right, so then looking at it, we would have for part A, find the probability of at least 1 coin coming up as heads. So with at least 1 coin coming up as heads, we could have 1, 2, 3, 4, 5, 6, 7 ways that happens. So 7 over 8, my total. Then we have, what are the odds that they all come up as heads? Well, my success, that would be 1. Over my failures, which would be that 7, which would give me my final answer. Find the probability of none of the coins coming up as heads. Well, if there's no heads, that would be our tail, tail, tail option. And that is going to be 1 over 8. And then lastly, we have find the probability of exactly 2 coins coming up with tails. So exactly 2 coins with tails. So I'm going to do that one in green. We've got 1, 2, 3. So 3 out of 8. All right, this is the one that will have a pretty large sample space, but we're going to create a sample space. If 2 dice are rolled, then find the probability of each event. Okay, so this is where we're going to take up some space. So I'm going to just start off by listing them out. So let's see, we'll have our, obviously with the first number being 1. Then with my first number being 2. And then we're going to keep going all the way down until we get to the 6s. I'm going to pause the video real quick and write them out, and then I'll restart back up. All right, so these would be our sample space. Now let's look at what they're asking for. So we have for part A, the sum of the numbers showing on the dice is going to be 10. All right, so we got to look and see where these dice are going to add up to be 10. Well, I can go ahead and ignore all of my 1s, and I can ignore my 2s and all of my 3s, because when I look at the max ones, I'm only going to get 9, 8, and 7. So we'll start off with our first one being that 4, 6. Then we could also do 5, 5. And we could also do, let's see, the 4 and the 6 again, but where the 6 is first and the 4 is second. So I'm going to write them out to help you see which ones I'm using. But I would be using here the 4, 6. We got 5 and 5, and then 6 and 4. So therefore, I would have 3 as my success is what I wanted. And then I would have 36 as my total if you count them out. And this is going to reduce to 1/12. All right, now let's look at, we've got part B. The sum of the numbers showing on the dice is at the least, so they can add up to 10 or be more. So we already know that we can start with that 4, 6. We can start off with my 5, 5. But we could also include that 5, then getting a 6. And then we could start off with the 6, 4, and then get bigger with the 6, then getting the 5, and then my 6, 6. So that's going to give me 1, 2, 3, 4, 5, 6 options that will give me what I want over my total amount, which is that 36, to give me 1/6. All right, then we've got at least one die. Okay, so dice is what that's referring to, is showing a 4. All right, so that could be, we've got 1, 4. We've got 2, 4. 3, 4. Then we've got the 4, 1. 4, 2. 4, 3. 4, 4, 4, 5, or 6. Then you've got your 5, 4, and 6, 4. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 successes, what we wanted, over my total 36. And that one doesn't reduce, so that would be my answer. All right, now we have all dice show the same number. Well, we've got our 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then 6, 6. All right, so that's going to be 6 over 36. And so we'll get 1/6 again. And then for our final one, we have one die shows an odd number, and the other is going to show a power of 2. So to clarify, for that power of 2, we would have like 2 to the power of 0, which is going to give me 1. 2 to the power of 1, which gives me 2. And then 2 to the power of 2, which gives me 4, which is where we stop. Because when we get to 2 to the power of 3, we would get 8, and an 8 is not going to show on our dice. So we're looking for a 1, 2, or a 4. So I'm going to erase that because this is where I'm going to write them all out. So we have one odd number, and the other is going to show a power of 2. So we've got our 1, 1. We have 1, 2. Then we have 1, 3. 1, 4. And 1, 5. Okay, then moving into my 2s, we'll have 2, 1. 2, 3. And 2, 5. Looking at my 3s, I'll have 3, 1, 3, 2, and 3, 4. Okay, for my 4s, we got 4, 1, 4, 3, and 4, 5. And then for my 5s, we'll have 5, 1, 5, 2, and 5, 4. And this is where we stop, because when we get into the 6s, we don't have that power of 2 and an odd number. And so we're going to just count out and see how many we have for successes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 over my total, which is 36. And that does not reduce, so that would be my final answer of this last problem for these notes.